Over the last 3 videos, we've talked about the 3 parts of the division limit law. So the first case was when the limit of the numerator was L, the limit of the denominator was M, and that was not 0. And in that case, we got that the limit of this quotient was just L over M. The second case was when the denominator approached 0, but the numerator did not approach 0. In that case, the limit does not exist. And then the third case was when the limit of the numerator and the limit of the denominator are both 0. And there, you have to do more work in order to figure out what's going on. Let's do some examples. So we'll start with this one. We've got the limit as x approaches 0 of this quotient. And then what's the denominator doing? If we just look at the limit of the denominator, well, that's a polynomial, so it's continuous, which means as x approaches 0, the limit of this denominator is just what we get when we plug in 0, and that's 2. Similarly, the numerator is a polynomial, so it's continuous, and its limit will be, well, when we plug in 0, we get minus 3. So the numerator is going to minus 3, the denominator is going to 2, and we're just in the first case of the limit law for division, and we're just going to go to minus 3 over 2. Okay, so what if we took the same limit, but we now have x approaching 1? Well, here, when we take the limit of the denominator, we can still plug in because it's still continuous, and we'll see that we get 0. So the denominator is going to 0, and we need to check the limit of the numerator, and we can plug in there as well, and that's also going to go to 0. So the numerator and the denominator are both going to 0. We're in this third case that we just talked about for the limit law for division. So we have to do more work. And most of the time when we have a numerator and a denominator that are polynomials and they're going to 0, the work that we have to do is factorization. So the top is going to factor as x minus 1 times x plus 3, and the bottom is factoring as x minus 1 times x minus 2. Aha! Well, we have a common factor here, so we can write x plus 3 over x minus 2. Now, one small point here, there is a slight difference between this function and this function, which is that this function is not defined when x is 1, whereas this function is defined when x is 1. That's the only difference. But we're taking limits, so the value of the function at x equals 1 isn't going to affect the limit as x approaches 1. So the two limits are going to be the same. Okay, so we've reduced the problem to this limit of this quotient. And now, if we look at the denominator, as x approaches 1, well, we can just plug in because this denominator is, again, continuous. So this denominator is going to go towards minus 1. And the numerator is also continuous, so we can plug in for its limit, and that's going to be 4. So the denominator goes to minus 1, the numerator is going to 4. By the first part of the division limit law, the limit of this quotient is going to be 4 over minus 1, which is minus 4. So that's the value of our original limit. Okay, let's do one other example. Let's say we have the limit of x plus 1 over x plus 1 over x plus 2 as x approaches minus 1. So as x is approaching minus 1, what's this denominator doing? Well, the x term is approaching minus 1. The 1 over x term is approaching 1 over minus 1, which is minus 1. And the 2 is just 2. So this denominator overall is approaching minus 1 plus 2, which is 0. And the numerator, as x approaches minus 1, is also approaching 0. So this is our third case of the division limit law. We have to do more work in order to figure out this limit. Can we factor this stuff? Well, not as is. We have this ugly denominator, and that's not so nice, but we can do some algebraic cleanup first. So we can multiply the top and the bottom by x, and that'll get rid of this fraction in the denominator. And when we do that, we get x squared plus x on top, and x squared plus 1 plus 2x on the bottom. And we're taking the limit as x approaches minus 1. So here, well, we still have both the numerator and the denominator going to 0 as x approaches minus 1, but now we can factor. So the top is x times x plus 1, and the bottom is x plus 1 quantity squared. And we're taking the limit as x approaches minus 1. So here we can cancel now, and we're going to get the limit as x approaches minus 1 of x over x plus 1. And when x is approaching minus 1, the denominator is approaching 0 again, but the numerator now is approaching minus 1, which is not 0. And so we're talking about part 2 of our limit law for division. The denominator is going to 0, the numerator is not going to 0. That means that this limit does not exist, and neither does the original limit. So that's how you use the limit law for division. We have plenty of exercises for you, so enjoy.